Alright, so for example 7, we're kicking up the difficulty a little bit here. So we have 100 Newton weight, so it's already in terms of force. We don't need to do anything there. Suspended from a ceiling by 2 ropes, and the one rope makes an angle of 30 degrees, the other rope makes an angle of 45. Determine the tension in each rope. So tension is actually a force here for us. So we see that we have tension number 1, the vector in red, making a 30-degree angle with the ceiling, tension number 2 making a 45-degree angle with the ceiling. And we also see here this black vector extending downwards, and that is the overall resultant force. Okay, so we're going to remember, and we're going to use this to our advantage, that the resultant force is actually the sum of the other two forces. Okay, so because this is the sum of the other two forces, we know that these three vectors are going to create a closed triangle for us. Okay, they're going to be in equilibrium with one another, and that's really going to help us. So the key to this whole question is getting the proper diagram. If we can get the diagram, the math behind it really isn't that difficult. So looking at this diagram here, hopefully you can convince yourself that we have the 30 and the 45, that a quick 180 degrees minus 30 minus 45 will get us this 105-degree angle between the two ropes. So now what we want to draw is, okay, and try and keep this on the screen. So what we want to draw is this diagram. I'll try and use the same colors. So we have the force here, the overall force acting downwards, and we know that its magnitude is 100. We have the blue vector up there, and remember, it's traveling up and to the right. So I'm going to try and do the same thing with my diagram here. So I'm going to have this vector traveling up and to the right, meeting there. And then finally the red vector, it's essentially going up and to the left. And so what that's going to do is there's my up and to the left, and it closes the triangle for us again because everything here is in equilibrium. So we have this blue vector is our tension 2. The red vector is our tension number 1. And we have the force. Now, the key is figuring out what are all the angles in this diagram. Once we can get that, again, the question is essentially done. So that's what we're going to work on next. So if I introduce a horizontal right here in purple, I introduce the horizontal, and then the vertical matches up perfectly with the black vector there. From our diagram, we know that this 45 that's up here, okay, with the ceiling and the blue vector, is actually right there for us. Again, imagine the purple, imagine your purple as the ceiling and the blue vector. So that means we have a 45-degree angle in there. And hopefully you can convince yourself, because from here to here is 90 degrees, 90 minus 45, we're also going to have a 45-degree angle in there. A similar argument can be made for the 30-degree angle we see in our diagram. So if I put in a horizontal down here and I have my vertical, well, the red vector, tension 1, had a 30-degree angle with the horizontal, and then a quick subtraction from 90 degrees, we can convince ourselves that the angle down here is a 60-degree angle. And the last step, we have our angle theta here, and not too complicated. We have the 45 and the 60-degree angle. So quick subtraction from 180 tells us that this angle in here is actually a 75-degree angle. So now what we're going to do, and this is where I stressed that getting the diagram was the most important thing. Now we need the magnitude of tension 2 and the magnitude of tension 1. Well, knowing all three angles and knowing one of the side lengths, F, we're just going to do sine law twice and we'll have the answer. So hopefully I can convince you of that with the circles I'm about to make. So we have the magnitude of F 100 and we have its opposite side. So we have that matching pair. We need magnitude tension 1 and we have its opposite angle. So again, a quick sine law setup will allow us to see that the following is true. So what I'd like you to do now is pause the video and see if you can come up with the magnitude of tension 1 as I'm about to. So hopefully this is what you came up with. Magnitude of tension 1 over sine 45 equals 100 over the sine of 75. Please don't forget, it is absolutely important that you have these magnitude symbols on there. It's not correct if you don't have them. So we get an approximate tension 1 as 73.2 newtons. And now reset and see if you can get tension 2 as well. So pause the video now and try that on your own. So hopefully this is what you came up with, the fact that tension 2 over 60 degrees is 100 over sine 75, and we get the magnitude of tension 2 as about 89.7, so we can conclude that the tension of the shorter rope is higher than the tension of the longer rope, which hopefully you can convince yourself should actually make sense. And we'll see you in